Hello dear friends, welcome my channels. Today's discussions is complex integrations around a small semicircle. To evaluate minus infinity to infinity fx dx, we consider closed C fx dx, where C is the contour consisting of the semicircle CR such that mod of z equals to r, together with the diameter that closes it. Supposing that fz has no singular point on the real axis, we have by the residue crfz plus minus rfx dx 2 pi I residue fa. This is the formula, friends. So friends, now I discuss a problem. Finally, r tends to infinity. If you see that if this r tends to infinity, so minus infinity to infinity fx dx, provided integration cr fz dz tends to r as r tends to infinity. So friends, evaluate question is evaluate x square dx x square plus 1 x square plus 4 c fz dz, where c is the contour consisting of the semicircle cr of radius r, together with the part of the real axis minus r to r. To the integrand has simple poles z equals to plus minus I, z equals to plus minus 2i, of which z equals to I 2i only lie inside the C. You see that only lie inside the C. So friends, how this problem I can solve? I can solve simple. You see, I apply this process. I apply this method. That's why I write it. This method, semicircular problem, is semicircular problem. So semicircular problem. So I have already drawn a semicircular CR R I, and you will see that I and 2I inside the C. When this kind of problem, so I have to find out by the residue theory, by the residue theorem, contour integral fz dz equals to 2 pi I residue fi plus residue f2i. Now how can I find out residue fi? Residue fi is equals to 2 pi I limit z tends to I z minus I fz and plus limit z tends to 2I z minus 2I fz, and I get the value is 2 pi I, and my function is, you will see that function x squared fz is simple, fz is z square divided by z square plus 1 and z square plus 4, and this function is, you have already seen that this function is singular point on the real axis, and this is continuous polynomial function. So I can easily putting this, and I square two I plus I square plus 4 I square divided by 4 I square plus 1 into 4I, and I get this value, this value pi by 3. Easily you can calculate, then you can get value pi by 3, and integration fz dz equals to whatever you see minus r to r fx dx plus integration cr fz dz equals to, so friends, equals that implies integration c fz dz equals to, if integration fz dz equals to this value I just put, I am putting this value. This value is pi by 3, and it is, when it is minus infinity to infinity, infinity x square divided by x square plus 1 into x square plus 4 dx plus 0, because this value is 0. How I get this value is 0? Because fz equals to 1 by z square 1 by 1 plus z to the power minus 2 1 plus 4 z to the power minus 2. This is the value, and this value is equal, this value a limit mod z tends to infinity, as r tends to infinity, so z tends to infinity, integration cr fz equals to 0. Show that minus infinity to infinity e to the power minus ax square plus b cos 2 root pi root a log 1 by 2 root a plus b x dx. So friends, this integration is very interesting. This problem is very important, interesting. So integrate fz when exponential is given. So integrate fz is equal to e to the power minus az square along the rectangle ABCDA. You will see that I have drawn already ABCDA, where A is equal to minus L, B is equal to L, C is equal to L plus IM, and D is equal to L minus IM. FZ has no poles inside the contour. As integration AB fz dz and integration BC fz dz and fz dz equals to 0, because by the Cauchy's theorem, there is no here there is no singularity. You will not see any singularity. That's why the total integration, the total line integral fz dz are all at 0. And let z equals to root over ax and bc is equal to l plus iy and ct is equal to z equals to root over ax plus im, and dA is equal to z into L minus iuy, and m is equal to log of root over 1 by 2 root a plus b. Because so you will see that it is moving minus L to L, and also this way this is moving. So I get the value minus L to L e to the power ax square, and another is 0 to m, and minus L to minus L e to the power root over ax plus im whole square plus m to 0 to m e to the power minus half l I whole square. And after that I get this value as we know that a plus b whole square is equal to a square plus 2ab plus b square. So I apply this formula, and I get this, because e to the power in here e to the power ax square, sorry, and it in here minus l square, in here you get minus l to l e to the power ax square, 0 to m e to the power minus l square, and it is minus, this value is minus and minus, in here it is y square, not m square, friends. It is plus y square, it is not m square, minus l square minus 2li plus y square minus l to l e to the power minus ax square minus 2I root over ax m plus m square, and this is the total calculations, friends. And another factor I dy, because you see that dz is equal to, you see that I dy, another is I dy, everywhere is I dy, because dz equals to, you see dz equals to number 1 I dy, and dz equals to root a dx, root a dx, in here root a dx, root a dx. This is the way I can get this dz is equal to root a dx, and it is I dy. And now you will see that L tends to infinity, then the last two integral e to the power minus L square I into 0 to m e to the power y square e to the power minus 2ly e to the power minus 2ly dy equals to this is tends to 0, and sine 2ly is finite, sine 2ly is finite, and reduces number 2, I reduces this because this point. So whatever I get, minus root over e to the power ax square. So e to the power ax square root a in here, and also in here also root a. However, root a cancel, no problem, root a is not a matter, but I have to write for my calculations. So we can get minus infinity to infinity e to the power minus ax square minus e to the power cos 2a. How can I get this value, friends? Very simple. You will see that ax square root a x plus im, this is whole square, so this value is ax square plus 2 into root over 2 into I root over a m x minus m square minus m square. So into e to the power, when e to the power ax square into e to the power 2I root a mx into e to the power, this is minus minus plus, because as minus is in here, so it in here it is also minus, so it is e to the power minus am square, it is minus, as there is the minus in here, so it is plus, so e to the power m square. This is the simple calculation, and you will know that e to the power de Moivre's theorem minus 2I root a mx is equal to cos 2 root a mx minus I sin 2 root a mx, because as the formula is e to the power ix is equal to cos x minus I sin x. This is the de Moivre's theorem. That's why I just put in here and I get this value, and this value equals to 0. So again I discuss that minus infinity to e to the power ax square is equal to e to the power m square is equal to these positions. These positions I get these positions, because m value is equal to I have already told that m is equal to log of 1 by 2 root a plus b. This is the log value, m square value, sorry, this is m square m value. So this is the m square, means this is square. Now whatever I have to prove, sorry, this is m square, so this way, this is this way. Now this is this way, so m square is equal to e to the power log, and another factor is that minus infinity to e to the power ax square minus infinity to infinity e to the power minus ax square is equal to root over pi divided by 2 root a. 2 root a, as x is equal to x square is equal to t, so x is equal to root over t, so e to the power minus infinity to infinity e to the power minus root a ax square is equal to t, so x is equal to root over t by root a, so it is e to the power minus t, and t to the power 1 by root a, t to the power minus half dt, so it is 1 by root a gamma half, so it is root over pi divided by root a. So this value, and now you will see that e to the power log 1 by 2 root a and e to the power b is equal to 0 to infinity e to the power minus a x square cos e to the power 1 by 2 root a e to the power b. It can be added in here, that 0 to infinity e to the power minus a x square plus b cos 2 root a root over log 1 by 2 root a plus b x dx equals to root over pi by 2 root a. So this 2 is cancelled, 2 root a is cancelled. So I get this proof easily. So friends, I can clear this concept, I hope. And next problem is very simple. Consider the integral 1 by c e to the power mij dz is equal to 1 by c fc dz, where c consists of 1 the real axis from r to r. So the upper half of the circle CR mod of z equals to r. The real axis is r2 minus r. The upper half of the circle CR is equal to mod z equals to r, small r. This portion is mod z equal to small r. And fz has no singular inside C, which has been deleted by drawing CR. We have the Cauchy's theorem r to r fx dx, these portions r to r fx dx, and this portion, this path integral CR to f r f dz, and minus r to r, you will see minus r to r fx dx, and orientation you will see, and CR fz dz equals to 0. Then now CR fz dz, CR, where is the capital CR? In this case, I just draw this case, 0 to pi e to the power I m r cos theta I sin theta r to the power I theta r into e to the power I theta, because I have already, my function is, what is my functions? I have to find out evolute sin mx by x dx is equal to 0 dx. Friends, I have already solved by it Laplace. It is Laplace theorem. I have already shown this value is pi by 2. Now I want to solve this problem by the Cauchy's theorem. So I have taken my complex integral is e to the power mz by z. This is my complex integral, and I discussed that z equals to whatever I might z equals to r into e to the power I theta, and you see that where is the small r, there is mod z. This is the two circle, one is the capital R, another is small r. So e to the power minus m r theta, wherever e to the power minus m r theta mod value, and you see that pi divided by m r e to the power minus m r. This formula is very important formula, friends, by the Jordan lemma. This lemma is called Jordan lemma. CR fz dz into 0 to pi mr sin theta into 2 into 0 to pi by 2 mr sin theta, because negative portion is, there is no negative portion, so this is, so I get pi by mr 1 by e to the power minus mr which is 0 as r tends to 0 infinity. And similarly CR fz dz and d theta, that value is minus I pi. So 0 to infinity fx dx is equal to 0 plus 0 to infinity fx dx. So this equals to minus infinity to infinity fx dx is equal to I pi. And now whatever you see that this value is I pi means minus infinity to infinity e to the power I mx dx, sorry, I mx dx, not I mx by x, I mx by x dx is equal to I pi. And comparing, and e to the power I mx means it can be written this way: minus infinity to infinity cos x plus I sin x by x is equal to I pi. Because I get I pi values from the small cr. This value is minus I pi, this value, and this value is infinite, 0. This value is 0 as r tends to infinity. So whatever I get this value is minus infinity to infinity sin x by x dx is equal to pi. Let's solve another problem. Get 2011. Let fz is equal to z divided by by 8 minus z cube. So find residue z equals to 2. Fz is, find the value of minus infinity to infinity fx dx is. So friends, at first I have to discuss Jordan lemma. Consider a complex valued function f. Define the semicircular contour, like this is the also semicircular contour, and cr is equal to r into e to the power I theta of the positive radius r is the upper half plane centered at the origin. If the function f is fz is equal to e to the power minus iz into gz, with a positive parameter, then the Jordan lemma states the following upper bound of the contour integral. This is the Jordan lemma. And where mod of fz cr dz is equal to pi by a mr, you will see, and mr is limit r tends to 0, mr is equal to 0. So the Jordan lemma is the r tends to infinity cr fz dz is equal to 0. Same case friends, here you will see, here you can see that this portion is 0. This portion is 0 by the Jordan lemma. So friends, I have to apply this problem, the Jordan lemma I have to apply. So whatever I get, fz is equal to z divided by 8 minus z cube, and whatever I have to find out, residue z equals to 2 fz into z minus 2 limit z tends to 2 into z into 8 minus z cube, limit z tends to 2 and z minus 2 also divided by z divided by minus 4 plus z square plus 2z, and this value is equals to whatever I get this value minus 2 divided by 4 plus 8 divided by 12 is equal to minus 1 by 6. And now I have to find out the integral value. Integral value is minus infinity to infinity minus infinity to infinity fz z dz. So this value I have to find out. So 8 minus z cube equals to 0. So z equals to 2 and z equals to 4 plus z square plus 2z equals to 0. So z equals to z value is whatever I get. Z value is minus 2 plus minus root over b square means b square is equal to 4 minus 16 4ac b square minus 4ac divided by 2a by 2. So whatever I get 1 minus plus minus root 3i. This is my total pole. So the first answer is minus 1 by 6. First answer is minus 1 by 6 and second, now I have to find out second answer. So second answer is minus infinity to infinity fx dx fz dz. I have to find out fx dx. I have to find out fx and dx. So friends, whatever I have to use the same process, but you will see that when there is two kind of pole, here is also a pole. This problem is same type of problem, this type of problem, friends. This type of problem that in here you get that 0 is the pole, so we draw a small r, but in here we get another point that is root 3i. That point is root 3 2 plus that point is minus 1. In here you see that inside C, no singular inside C, simple pole at z equals to 0. Only singular point. Like this type of problem. First problem you see the 2i and I. Okay, this is the singular point. And here singular point is z equals to 2, so this is the singular point. 1 plus root 3i. 1 plus root 3i is the singular point. So this is the root 3. This point is root 3. Root 3 means 1.732 something, and 1 is the inside this point. This is the root 3 and 2 is the another point. So whatever I have to find out, this type of problem, friends. This is in here you see that where this problem sin mx by m, here you see that the two type of problem 0 and r. So you get also 2 minus r and 2 plus r. And r is the radius. and this point is 2. 2 is the point. This is the 2. 2 is the point. Here it is also. Here you can get the singular point is 2. So 1 plus root 3I is my another point. You can get this point also in here, because between this line 2 minus r and 2 plus r. So whatever I have to find out, at first I apply Cauchy's theory. Integration c fz dz I have to find out. How can I get this? I can get this value is, at first you see that 2 plus r 2 plus r 2r. So my value is 2 plus r, 2 capital R, and fz dz, and after that you get the value r2 minus r. So this value is r2 r minus r. The path is gamma. I just write gamma path and fz dz, and after that minus r2 2 minus r. So the value is minus r to 2 minus r fz dz, and 2 minus r to this path is, I can write this path is like a gamma path, gamma. So this path is gamma path. So I write gamma and fz dz. This is the total process, friends. I have to find out all the values. At first I have to find out fz dz, this point, by the Cauchy's theorem. So how can I get this? This value is residue z equals to minus 1 plus root 3I you will see that, friends, in here we don't need to find out because in here it is 0. In here it is 0 because you see that in the upper plane there is no singular point. There is no singular inside C. But in here you see there is the singular point 1 plus root 3I. So 1 plus root 3I is the 1 point root 3I. 1 plus root 3I is the singular point. So I apply the Cauchy's theorem is the residue z equals to minus 1 plus root 3I fz. Very conceptual problem. This problem is very conceptual problem. And why do I take the 2 is the my point? Because 2 is the real line. You have to see that z equals to 2. Z equals to 2 lies on real line, and I have already draw a circle. I have already a path which avoid the point 2. This is this circle avoided this point 2, and I take this is the technique, and I draw a small radius. This is a small r, because I avoid this path in my area, in my contour. So So that friends, you see that I only one residue, that is minus 1 plus root 3 I. So minus 1 plus root 3 I means in here minus 1 plus root 3 I. And after that I have to calculate the value. How can calculate is limit z tends to minus 1 plus root 3 I divided z divided by 1 plus z 1 plus. So friends, you see that z minus whatever you get z minus 2 into z plus 1 plus root 3I, as the formula is 8 minus z cube, so I can write this way, and this is the minus is minus, and also 2 pi I multiply 2 pi I. So friends, you will calculate, and whatever you will calculate, you get root 3 plus 3I, root 3 plus 3I divided by 12 root 3 into 2 pi I. And after that friends, whatever you see, gamma tends to 0, r tends to infinity. So whatever I get 0 to infinity, fx dx plus 0 to plus minus infinity to 0, fx dx minus whatever I get, minus value is this value gamma fz value. So friends, gamma fz value is I have to find out gamma fz dz, where circle is semicircle, gamma fz dz. So if this circle is limit z tends to 2 z minus 2 fz equals to, I get 1 by 6 minus 1 by 6. So another vector is this is the semicircle, so it is 2 pi I not pi. So this value is pi I divided by 6. Pi I divided by 6 equals to whatever I get, I get 2 cut, this is 6. So it is, this value is minus pi I by 6. Friends, you will write down everything, because I just removed this portion and I write it again, minus pi I by 6 and minus pi I root 3 minus plus pi I root 3 divided by 6. So this portion and this portion's cut, and whatever I get minus infinity to infinity fx dx equals to pi I root 3 divided by 6, and this value is minus, value is here not is pi I, this is only I, pi root 3 divided by 6, and it is minus pi by 6 root 3. Now friends, another question is summation m equals to infinity to bn zn Laurent series expansions, the functions z by sin hz 0 to mod of z less than pi, then find b minus 2, b0 and b2. I have to find out. So friends, sin hz 1 by z divided by e to the power z plus e to the power minus z divided by 2 sin hz is, because sin h hz is equal to e to the power z into e to the power minus z divided by 2, and this is, it can be written this way: 2 divided by z into e to the power z plus e to the power minus z. It can be written this way, and after that I just use exponential formula. E to the power z is equal to 1 plus z square by 2 factorial and z cube by 3 factorial. I apply this formula and I can write this way, that 2 divided by z into 1 plus z square by 2 factorial plus z cube by 3 factorial, this is, and plus 1 minus z plus z square by 2 factorial up to infinity. This value I know, and after that sin hz can be written. So friends, it can be written this way. If we calculate, then we can get 1 by z square, 1 minus z square by 3 factorial, z to the power 4 divided by 4 factorial, this is up to infinity, plus z square by 3 factorial plus z to the power 4 by 4 factorial plus 0 up to infinity. So you plus 0 up to infinity whole square. Neglecting higher term, so whatever I have to find out, I have to find out b0, b minus 2. So my b minus 2 is equal to, this value is b minus 2. b minus 2 is obviously 1, because otherwise everything is higher term, and b0 is equal to, my b0 is equal to 1 by 6, 1 by 6 as 3 factorial, z square cut, so 3 factorial 6, and my b1 is b2 is equal to 7 by 360. This is my total formula, friends. Because 7 by 360, b2 means b2, the Laurent's theorem, b0 is equal to, without z term, without z means constant term, and b2 is equal to 1 by, b2 is equal to z square, that value is 7 by 360, because 4 factorial, 1 by 4 factorial plus 1 by v2 is equal to coefficient of z square. If you calculate, then you can get 7 by 360. So friends, this way I can get. Another formula is, another question is 6. Question 6 is that summation n is equal to z plus 1 whole to the power n, fz is equal to sin z in z divided by z plus 1. How can I find this? So friends, Laurent formula, a minus 2 is equal to 1 by 2 pi I contour integral c into z plus 1 into sine 1 by z plus 1 into dz, and here is no singularity. Next formula, next problem is sin x divided by x into x square plus 1. This type of problem is that minus infinity to, very shortcut way, minus infinity to infinity, infinity to infinity, fx dx divide fx dx is equal to pi by a square into 1 minus e to the power minus a, and here fx is equal to sine ax divided by x into 1 plus x square, and in here a equals to 1, so the value is pi into 1 minus e to the power minus 1. And next problem is, because this problem is gate problem, friends, as the gate problem, so I need to shortcut process. Another problem is, let S be the positively oriented circle given by z minus 3y equals to 2. The value of S into z square plus 4. So how can I find out this problem, friends? This is the last problem. If I draw a circle z equals to 2 plus 3i and z equals to minus 2 plus 3i. This is my center. So my center is minus 3, my 3i is my center, and my radius of the circle is 2. Radius of my circle is 2, and now z square plus 4 equals to 0. So z equals to plus minus 2i. So friends, you get that minus plus 2i inside the plus 2i. So integration dz divided by z square plus 4 equals to limit 2 pi I, limit z tends to 2i z minus 2i 1 by z square plus 4 equals to 2 pi I 1 by 4i is equal to pi by 2. Thanks for watching.